All right, welcome to The Explainer. Today we're going to tackle a concept we use all the time, a word that feels so fundamental to how we see the world, but what if it's just an illusion? I'm talking about complexity.
Now, I know this question sounds kind of absurd at first, right? Of course, a person is more complex than a rock. But stick with me, because this idea challenges one of our most basic assumptions that a living, breathing thing is just fundamentally more intricate, more special than an inert lump of matter. What if that whole distinction is just something we made up?
So, to even start unpacking that, we first have to understand the standard, common-sense view of biological complexity. This is the starting point for pretty much every discussion about what makes life, well, life.
And here it is. This is the argument, famously put forward by thinkers like Richard Dawkins. The idea is that when you look at an eye, or a wing, or even a single cell, you're seeing something so organized, so functional, that it seems astronomically unlikely to just happen. It basically screams out for an explanation. And for science, of course, that explanation is natural selection.
Okay, but now let's flip this whole thing on its head. Let's bring in a really powerful counter-argument, a skeptical view that tries to tear that entire idea down. And it asks a really simple but deep question. Are we just focusing on the properties that we find interesting?
I mean, look, at first glance, the difference is night and day. An organism replicates, it adapts, it metabolizes. A rock just sits there. We see all these properties, and we call them complex. But the skeptic would argue these are just features we've decided to label as special. From a purely physical point of view, they're just behaviors of one particular jumble of atoms among countless others.
And that's the absolute core of this challenge. From the perspective of fundamental physics, any specific arrangement of atoms is super improbable. The unique configuration of atoms that makes up your brain is just as unlikely as the unique configuration of atoms in some random rock on Mars. One isn't inherently more special or more in need of an explanation than the other. They're both just arrangements.
Okay, so this leaves us in a really fascinating mind. If we're going to settle this, we can't just go with our gut feelings. We need like a complexity meter, an objective scientific way to actually measure it. Because if we can't measure it, can we really truly say it exists? So let's see what science has come up with.
So, how in the world do you measure something so abstract? Well, scientists have been grappling with this, and they've proposed a few different frameworks. We're going to take a look at 3 of the biggest attempts to create that ruler for complexity.
But, and this is the really interesting part, as we're about to see, each of these seemingly solid scientific metrics, well, they kind of start to fall apart when you look at them too closely. This is where the case for complexity being a human invention gets really strong.
First up, we've got Kolmogorov complexity. The idea here is actually really elegant. A simple pattern like AB, AB, AB is simple because its description is short. Just repeat AB 3 times. But a totally random string of letters is complex because the shortest way to describe it is, well, to just write out the whole thing. The idea is simpler things have shorter descriptions. Makes sense, right? But here is the fatal flaw. What if I just invent a new programming language, and in my language there's a single command? Let's call it the make a human brain command. And it does exactly that. Well, all of a sudden, in my language, the description is incredibly short. See the problem? Complexity here isn't a property of the brain itself. It's a property of the language we choose to describe it in. It's totally subjective. Okay, so if the description length is subjective, what if we try to measure the information itself? This brings us to information theory. This approach links complexity to the amount of information a system can hold. You can think of it like this. The more possible ways the atoms in a system can be arranged, the more information it contains, and so the more complex it must be.
But this is where this metric just completely hits a wall. From a microphysical view, a rock and a brain of the same mass are both just these enormous collections of particles, and each one has a similarly massive, almost incomprehensible number of possible quantum states and arrangements. So, according to this metric, their information content could be pretty much the same. It totally fails to tell the difference between what our intuition says is a simple rock and a complex brain.
All right, so both of those attempts kind of failed because they were way too abstract. So what if we try something more concrete, something that feels really intuitive, especially for biology? This is hierarchical complexity. It basically says something is complex if it has layers of organization. Atoms make molecules, molecules make cells, cells make tissues, tissues make organs, and so on. The more of those functioning layers you have, the more complex the system is.
But again, this whole thing depends entirely on an observer. It's us, as humans, who decide that a tissue is a meaningful level of organization that's worth counting. Physics doesn't recognize tissue as some fundamental category. We're the ones imposing these levels onto the system based on what we find functionally interesting. So the metric isn't actually in the object, it's in our way of looking at it.
So, if none of the major scientific metrics for complexity can really stand up to scrutiny as being truly objective, where does that leave us? Well, it forces us to consider a pretty radical redefinition of what we're even talking about.
And this really is the big takeaway. Complexity isn't out there in the world, just waiting to be measured with the right tool, like mass or electrical charges. It doesn't seem to be a fundamental property of reality at all.
Instead, what we should probably do is think of complexity as a lens we use to view the world. It's a powerful human concept, right? A label we apply to systems whose patterns are interesting or useful to us. It's a practical tool that helps us make sense of things, especially systems that adapt and self-organize. But it's a tool that we made.
And this just completely reframes the entire debate, doesn't it? We aren't discovering complexity out there in nature. We are inventing it as a way to describe the things we find remarkable. The argument isn't really about physics anymore. It's about human perception, human values, and human categories.
And so, we end up right back where we started, but with a completely new perspective. If complexity isn't a real physical property, does that make life any less special? Or does it just mean that life's specialness isn't something we can measure with a ruler? Maybe our sense of wonder isn't about some objective metric, but about a value we consciously choose to assign to life's remarkable, unfolding story.